gonna get an oscilloscope fixed today, cubby. My 7834, my favorite oscilloscope, stopped working and the power supply started ticking. So that's what we're going to do today. We're going to take her open and open her up and see what's wrong. Cubs. Let's sit you down. Ah. Oh, what a beauty. First things first. Okay. Let's do calibration voids. Whatever. We're gonna find somewhere where the supply voltages are accessible. I usually have a bunch of test points. Okay. Might be something with the power supply. I don't know. My other scope's capacitor was dried out, so I had to replace the capacitor on the other scope. I had to identify and replace that cap. And the power supply for this one, it's a little bit more full. You know, they didn't waste as much space. Being a 4-slot bay, you know, some of the big scopes like this are just more air than scope. So here are the probe power jacks. So what you would do is you'd have some powered probes and you stick them into here, and we're gonna get the multimeter on that. I don't know what the problem is, but I know that we don't have a trace. We don't have anything turning on, so I'm going to assume it's something with the power supply. I don't know what it could be. Maybe I just ran it for too long and something gave out. Probably a capacitor, and if it is a capacitor, it's probably just one. Okay. So that's our power supply ticking. So we're not getting any of the supply voltages. I'm going to put this on the scope. Oh, you see this? How the fan is keeps stopping? Maybe if I just spin the fan, it'll start working again, right? Whatever. So when you have like the power supply bugging out, you have these neons and they tick. So you'll have some voltage, it builds up, and then it gets released. The neons. And the neons are pretty much telling you that you have a problem. So I want to take a look at that. I think it might be interesting to see what's going on in this I think this has got to be the high voltage. Okay, high voltage inside instrument. So they put like the Z-axis stuff. This is the Z-axis. I'm not talking about you. This is interesting. That must be a resistor, a trimmable resistor. It must be a precision resistor that they trim. That's what it looks like, at least. They have these film resistors, and they put it on, and then they trim it. One of the biggest problems for the 7834 oscilloscope mainframes is that the high voltage transformer gets shorted out. So I hope that's not what happened. basically I'm going to pop this cover off and I'm going to see what the high voltage section looks like. So right here are is the winding for the primary of the high voltage transformer. So this is the multiplier on this side, from what I can tell, and on the other side is our transformer. So let's capture that and save. So we're looking at 100 volts peak to peak. I don't know if you can see that. 100 volts peak to peak. So that's for one side. So I expect the other side to be opposite. So 180 degrees out of phase, or the opposite. And this is the other one. Same type of deal. I don't know. I really don't know. It's an adventure. I'm going to pull out the rest of the power supply. This is a simple power supply. Let's go, let's go, let's go. Okay. Okay. I like that. That's way easier to get out than the 7613. That's so much easier to get out. I hope there's something wrong with the power supply, so there's nothing wrong with the transformer. Maybe that's why we're getting the neons, because I feel like the neons are here to kind of let down any voltage from the CRT shutting down. Maybe I feel like that's one of the purposes of them. So I'll get the case popped off of this power supply. I bet you there's something else that's ticking away inside it. Oh, should probably unplug it too. Now we're gonna lose track of the screws. I think they put extra screws in them anyway, so if you end up with one screw at the end, the thing still works. They're clever engineers, they put extra screws all the time. Oh, this comes off. And the other side should come off. Okay. I'm definitely not going to rouse screw. But okay. Maybe some point. Okay. So I think I'm just going to check some voltages here in the power supply. I doubt that these sprogs pooped. I don't know, I had a sprog in the other power supply that was reading like 3 microfarads when it was supposed to be like 15,000. So maybe it's worth it to check those sprogs. Well, today is another day, and what I found is there's a fault condition that's making this integrated circuit shut down the inverter. So pin 13 is a current sensing pin. Pin 13, when it's brought low, it turns the inverter off. And that's what's happening. Is that we have something that's drawing current, I don't know what, and it makes the inverter turn off. So you have a starter, and you have the inverter. And the starter is kind of like, it's kind of like if you have a car. You have a car starter, and then you have the engine itself. So you want to get the engine running, and to get the engine running you need the starter. So this circuit this power supply has a starter, and the starter is down here. So this capacitor, I think it's this capacitor and this inductor, what it does is it forms an LC resonance circuit, and you have some transistors. I think they're these whatever. And what it does is it provides like a kick to get the inverter started, and then the starter turns off. Well, the problem is the starter works fine, but the problem is the oscillations can't continue because this chip senses a fault. And the fault is that you have some current being drawn. Now, how does it know where that we're having an overcurrent condition? It's through this little donut, this interesting toroid that they put, I think this is like a rubber grommet, put it in the circuit board. Now, I don't know how to troubleshoot switch mode power supply from the 80s. Tech Wiki, I found that the 7904 mainframe has basically the same power supply, so I can expect to find the same A14 board and A11 board, which are the cap rectifier board and the something or other. And what I'm going to do is I'm going to get that power supply taken out here. I'm going to unhook all of them, and then we're going to go through each section with the curve tracer to kind of feel into the circuits and see where the difference is. Because if I have one that works and I have one that doesn't work, and then I can kind of feel around, well, the differences should be what makes this one not work. So there might be a component that's shorted or has gone out of value, and it's making the circuit not work. It makes the power supply tick. Ah! Well, there you go, folks. I caught that on camera. Discharge your CRT before going poking around in it. Whew. So an interesting difference to note would be where the high voltage transformer is located. So in this board over here we see a header, and that's supposed to go, that goes to these cables, and it goes to the high voltage transformer, which they put over here next to the neck of the CRT. And then that's why I saw a whole bunch of empty space here, and I was like, oh, well, what goes there? Well, on this other power supply, what they did, that's interesting. Look at these caps. Anyway, so on this other power supply, what they did is that's where the high voltage transformer goes. So you have this regular switching transformer, and then you have the high voltage transformer right there, and you have they must have the voltage multiplier in there too, and then it goes straight to the CRT. So we're going to feel around here, and we're going to see what the differences are. I'm going to go through each of the sections, kind of probing around just to see if there's like any anomaly, because I really don't know what's going on, but that doesn't mean that I can't find the difference and see what's not working through the curve tracer. So on a closer visual inspection, I happened across this Sprague capacitor. I was just appreciating how much larger they are than on the 7904 power supply. And I go over here and I see this capacitor. And this capacitor does not look to be very well. So that is probably the smoothing capacitor for like a, what is it, 25 volt. So it's got to be like the 15 volt supply, negative 15 or positive 15 volt supply capacitor, and that's probably responsible for filtering it. So I'm going to have to desolder this capacitor, and then just put it across the meter to make sure that it's the bad capacitor. Maybe I'll pull up the leads on these ones just to make sure that they're in working condition. And then I'm going to find a suitable replacement. So 330 microfarad. I want to get a 330 microfarad cap with at least 25 volts DC. Okay, so we're going to put the capacitor up on the meter. And it gives us a whopping 1.2 nanofarad. So 0.001 microfarad. And it's supposed to be a 330 microfarad. So there's your busted cap, I guess. I operated the oscilloscope for like 4 hours straight, and then it just couldn't take it anymore. So here we have the leads pulled out, and this first cap comes in. It's supposed to be 330 microfarad. So here's a 382, 390, okay. This one's supposed to be 1000 microfarad. And that gives us about 1200. Okay. And this one is supposed to be 1000 microfarad as well. It gives us about 1200 as well. Okay, wonderful. So there's basically just this cap right here. I'll solder back these, then I will find a replacement for the other one. Just solder that back. That's happy. Solder this back. That's happy too. Make sure I get the plastic casing on the cap. That was always happy. Wonderful. Okay, this is not name brand as far as caps go, but I think it'll work. Just placing the cover on top, it seems like we do have enough clearance. Seeing these holes align, we should get by. There's some 5 millimeters of clearance there. I think we'll do fine. Oh, it still ticks. Oh goodness. I'm so sorry I didn't catch the moment with you. We have very exciting news and very sad news on the healing bench. So here is my 7904 power supply, and I was using it as a reference to fix my 7834 power supply. After booting on for like 4 seconds, it let out the smoke. Neither of them would work when the loads weren't connected. I looked it up in the forum. There were a couple of gentlemen that said you need to connect up the oscilloscope because the switch mode power supply is very, very picky. If it doesn't have any load, the voltage spikes up, and then once the voltage spikes up, it goes into over voltage protection, and you're not able to have any of the circuits like self-regulate, and it just turns down, and you get ticking, 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 even if you have all of the supplies disconnected. I turn it on. Oh, and there's no ticking, and the fan blows, and if the fan is blowing, that means something is working. So let's take a look at the front. Oh, beautiful! So there you go. the power supply is really notorious for problems. Maybe I'll look at that some other day, but it already has focus issues, and maybe I'll have to learn a little bit more before going back to service this scope. But for now, that's all the problem that was in this oscilloscope. So now I have my 7834 back, and I'm very happy. But here we go. Indicator lights, and slowly brings up to voltage. So, oh, because it's in variable persistence mode. There you go. So we have the vertical position, that channel, and this channel. Put this on Alt. Just get this channel too. And we have this time base. Slow it way down. Look at that variable persistence. Let's put the persistence up. Oh, just beautiful. That was the fix of my 7834 storage oscilloscope. 400 megahertz beauty from the 80s. I didn't know it would cost me another oscilloscope, but there you go. Oh, my beautiful 7834. That's right. Now, fix oscilloscope covers. You know what I'm going to do to celebrate is I'm going to get myself a frequency counter. Get myself a frequency counter plug-in. Oh yeah, covers.